In class today, we discussed solving literal equations. We talked about using inverse operations to solve literal equations. So our inverse operations are operations that undo each other. The first of which is addition and subtraction. The second is multiplication and division. And one that we're going to actually use in this lesson is squaring something and taking the square root, because those two operations undo each other. We also talked about solving using SADMEP, aka going in reverse order of operations. So to solve, we go in reverse order of operations. The first example I wanted to do was number 5 on your homework, which is solving the area of a circle for the radius. So I asked myself, what's happening to r squared, or well, to r, using order of operations? PEMDAS, the E stands for exponents. So the first thing that's happening is that r is being squared. R is then being multiplied by pi. So to solve using SADMEP, to reverse the order of operations, I'm going to use the inverse operation of dividing by pi. So I'm going to divide both sides of my equation by pi. My new equation is a divided by pi equals r squared. I still have to get r by itself, which it's not right now because it's being squared. The opposite of squaring something, the inverse operation of squaring something, is taking the square root. So by taking the square root of both sides of the equation, the square root of r squared is just simply r. So r ends up equaling the square root of a divided by pi. In the next example, I'm asked to solve for p. In number 7, I'm asked to solve, for r. So again, I ask myself, what's happening to r? Well, r is being multiplied by p and by t, and then it's being added to p. So to solve, I work in reverse order of operations. The opposite of adding p to both sides is subtracting p. So I'm going to subtract p from both sides. P minus p cancels, and I'm left with a minus p equals PRT. To undo the multiplication of p and t, I'm going to divide both sides by pt. So I divide both sides of my equation by pt. And I'm left with a minus p divided by pt is equal to r. Now you might be tempted to cancel out the p's. You might be tempted to cancel this p with this p. You're not actually able to do that because all three terms do not have a p in it. So we are not able to cancel out the p. So our final answer is a minus p divided by pt. The next equation asks me to find b. So this is number 9 on your homework. Again, I ask myself, what's happening to b? Well, it's being multiplied by 1/2 h. So to solve, I'm really going to do this in 2 steps. I need to undo the multiplication of h, so I'm going to divide both sides by h. Now I'm choosing not to divide by the fraction, which I'm going to show you why in just a second. My new equation is a divided by h equals 1/2 b. The reason I chose not to divide by 1/2 is because fraction division is the same as multiplying by the reciprocal. So I'm going to actually multiply both sides of my equation by 2/1 instead of dividing by 1/2, because dividing by 1/2 gets a little messy sometimes. So I'm going to multiply instead by the reciprocal of 2/1. So my final answer is 2a over h equals b. 1/2 times 2 cancels to be just 1, because anytime you multiply a reciprocal by itself, you get 1. So my final answer is 2a divided by h equals b. The last problem I'm going to go over with you is number 11, solving for p2. In class, I told you there was 2 ways to do this. The easiest way might be to take cross products. So cross products, remember, is when you multiply the numerator and the denominator of one side to another, and the numerator and the denominator of the other side to one another. So I get P1 V2 equals V1 P2. And again, I get that just from multiplying my diagonals together. And so I'm solving for P2. So if I ask myself what's happening to P2, well, it's being multiplied by V1. So to solve, I simply need to divide by V1. So I'm going to divide both sides of the equation by V1, and I'm going to get that P1 divided by P1 V2, V2 divided by V1 equals P2. And that's your final answer.